If you're dealing with a dataset that has a quantitative column that varies over time, like this dataset here, CO2 concentration over time, then it makes sense to use a line chart. We'll discuss Markdown links, JavaScript dates, d3.scaleTime, parsing dates with d3.timeParse, d3.line, and fill and stroke on SVG paths. Climate change is related to atmospheric carbon dioxide over time. I'd like to use D3 to reproduce what's called the Keeling Curve. This is a line that shows how atmospheric carbon dioxide increases over time. It's based on measurements taken at the Mauna Loa Observatory in Hawaii, named after this guy Charles David Keeling. The raw data is posted as CSV on this website here. So I'm going to download it and take a look at this file. Here's what we see. It's not well formatted CSV. Actually, it's got all these comments in here. But if you scroll down a little bit, you do get the nicely formatted CSV. In order to reproduce this graphic, I'm going to drop that CSV into VizHub and then write some code that creates this visual. I'll start by forking this scatterplot example, and I'll call it Keeling Curve. The first thing to do is to drop the data into here. I'm going to delete this iris dataset and then copy the valid CSV from the Keeling Curve data and then paste it in here. All right, we've got our data. In terms of our columns, we've got year and month. These will be combined to form the dates that feed into the x-axis. I'm not sure what exactly all these mean, but we can plot them and find out. One of the first things I'll do here is update the README, a reproduction of the Keeling Curve. And I'd like to link to that Wikipedia page. In Markdown, which this file is, this .md file, you can make links by surrounding text with square brackets, followed by parentheses, and then you can drop the URL into these parentheses. So I'll grab the URL for the Wikipedia article on the Keeling Curve and drop that in there between the parentheses. Now you can see in the description, this is a clickable link. I also want to cite this data source. So I'll grab that URL and add a section, data downloaded from, and I'll paste that URL there, and I'll call this Global Monitoring Laboratory Trends in Atmospheric Carbon Dioxide. Okay, now we have those two links there. Our README is complete. Now we need to just modify this viz to be specific to this dataset instead of the iris dataset. The first thing to address is the data parsing. All of this stuff here is specific to the iris dataset, so I will delete that. To get a sense for what we're dealing with each row, I'm going to console.log data at index 0. This will be the first row. And here we can see that's an object that has a property called average, which represents a number, but it is actually a string. So we can parse this into a number with d.average equals plus d.average. And we can do the same for deseasonalized. There we go. We're parsing deseasonalized. Now I'd like to parse the date. How should we parse this date? Well, first a little context. In order to make the x scale based on time, we should really use d3.scaleTime in place of d3.scaleLinear. This is a time scale, which is a variant of linear scales that has a temporal domain. This is good to use because it's aware of all the intricacies of time, and that comes into play, for example, when you add tick marks and tick labels. In order to use d3.scaleTime, the data should really be in the form of dates. In JavaScript, dates are first-class citizens. JavaScript date objects represent a single moment in time. For each of our row objects, I would like to define d.date to be an instance of a JavaScript date object. But what we have to work with is d.year, which is a string like 1958, and d.month, which is an integer like 3 here, and I guess 3 would represent March. So let's start by just getting our ingredients in place. d.month and d.year. But how do we get from here to a JavaScript date? Well, this is where d3.timeParse comes in handy. This wonderful D3 time formatting example by Zan Armstrong gives you a sense of how this works. D3 time parse and time format, which is its inverse, these are based on this specific string, which is a format specifier. If we generate a string, kind of like this, 1986-01, we could use a formatter like this. %y to indicate it's a year, a dash, just corresponding to our dash there, and then %m to represent a month as an integer. And we could easily generate this string based on the information we have. We can do that by generating a string with d.year dash d.month. And we can pass that through a function called parseDate, which we can define as an instance of d3 time parse using that special formatter string, this one here, which I'll copy out of here and paste into our code. Time parse is not defined because we need to import time parse from D3. I'd like to see this result, but our console.log actually comes before our for loop where we parse the data. So I'll just move that console.log to come after that. Now we can see that that date was parsed correctly. It's March 1st, 1958. All right, fantastic. That's how you can parse dates with D3 time parse. Now we are in a position to customize the invocation of our scatter plot, where the x value will return d.date and the y value will return one of those numbers. Let's try deseasonalized. And check it out, that sort of worked. All right, this is exciting. Check out the tick mark labels though. These are not quite right because it's still using scale linear, not scale time. In our scatter plot, I'm just going to change scale linear to scale time, which we need to import from D3. And now we get nice labels corresponding to the years. Now we need to definitely change these labels for the axes, which are defined right here. I'll just call it year to keep it simple. And for the y-axis label, I could call it deseasonalized, but that's kind of a very domain-specific term. Let's see what they call that in the Wikipedia article. CO2 fraction in dry air. And some kind of a chemistry unit. What is that? Micromoles per mole? Okay, well, I think I'll call it CO2 concentration. Okay, this is looking a little better, but the circles are too big. They kind of obscure the pattern. Let me make these circles a bit smaller. The radius is hard-coded here to be 10, but ideally I could tweak this in the same place that I'm tweaking everything else. So I'm going to make this a variable called circle radius, and then pull that in from our props here. And then in viz.js, when we invoke this, we can pass in circle radius. I'll set it to something tiny like 2, maybe 1. Okay, interesting. So this is deseasonalized. I guess this means that we're not going to see those patterns, those cyclic patterns. Maybe let's try average as the y value instead of deseasonalized. All right, that looks more like it. That's what I wanted to see. We get these nice seasonal variations. Now, while this does function as a scatter plot, I think this would make more sense as a line chart from a visualization perspective, because these are samples of a value that changes continuously over time. So I think, conceptually it makes sense to connect these dots. We can do this using a D3 line generator. Here's a nice example with dates and numerical values. It shows that we can construct a line generator like this, and then configure the X and Y accessors. So let's do this. I'm going to copy this snippet of code, and then I'll drop this into our scatterplot component. First, we need to import line from D3. And in the example code, I believe X and Y refer to X scale and Y scale, which are the same functions that I've defined earlier to position the circles. So I'll just drop those in there. And then to use this, I'll assign it to a variable called line generator. And I'll put this after our circles. Now this line generator will spit out a string that we can use with SVG Paths. Check this out. Console.log, line generator, and we pass data into it. This generates this huge string, which we can use as the D attribute of an SVG path. So let's do that. I'm going to make a single SVG path by saying selection.selectAll path.data, an array with a single element, because we just want a single path, .ettrd, and then I'll pass line generator of data, and then format that. Okay, let's see what we've got here. It seems to be suffering from some kind of offset, but it's basically working. I don't immediately know why this is, but I noticed that this line for the y-axis is missing the domain path of the y-axis. So probably that's what it's doing, is it's catching that because it's, inside of the same SVG element. So to solve this issue, we just need to be a little more specific. This selection.selectAllPath was getting the domain path from the y-axis. So in order to make that not happen, we can give this a class. I'll call it line. We can select against that path and then also set the class attribute to be line. Okay, that did not work. No idea why. Oh, maybe it did, but I just need to set the stroke. Oh, sorry, I think I missed the join. Ha, silly me. Okay, there we go. By default, the fill is black. So to make that not happen, we need to set the fill to be none. And there we have it. A reproduction of the Keeling curve. Those circles are still there, which is it's kind of a nice technique because it does let you see the underlying data. But you could just, just as well take those out by just commenting out the code that renders the circles. And now what we are left with is not a scatter plot, but rather a line chart. So I think I'll just rename this file, this module, from scatterplot to line chart, and then I'll update the export and update where it's called and update the import. And there we have it. A reproduction of the Keeling curve as a line chart.